Mm. Hello guys, my name is Yeppy Mangun Puspitajudin. I'm a student from Mercubuana University. So I'm majoring informatics, computer science, and in this video I will like a Q&A about natural language processing, ENP, NLP. Okay, so this video is just a part of my assignment from my lecturer in natural language processing course. So the lecturer is Mr. Henry Noprison and assisted with Mrs. Vina Ayumi. Okay. So let's going to the first question. What is the definition of NLP? Not neuro linguistic actually, but this is a natural language processing. So this is broadly defined as the automatic manipulation of natural language like speech, text, like used by the software. And for the second question, apart from text segmentation, what are the challenge of data processing of research in the field of NLP? Working with natural language processing, data is not solved yet. It's hard because it's messy. Human language are complex, highly ambiguous, and it is also ever changing and evolving day by day. So, because people are great at producing a new language and understanding language like slang language, and so it is harder to define for NLP what people saying if it's not fluent in English and formal English. So it is hard to define in NLP if the people use not formal English. So they use slang or something that uh, their new language. And number three, what is example of implementing NLP in software? And you may know smart assistants like Siri from Apple, Alexa from Amazon, and also smart assistant from Google. That I think from Google is has no name, so we just say smart assistant from Google. So we can say Alexa, hey Siri, hey Google for asking a question, and they will understand. They will say and respond with relevant answer based on context we just said before. That's amazing. That works because of natural language processing. So yeah, that's the number three answer. And for number four, what is the use of NLTK and Sastrawi libraries? So NLTK has been called a wonderful tool for teaching and working with computational linguistics using Python, and an amazing library to play with natural language, especially for Python language. And so NLTK is a tools, a library to help the programmers, to help the scientists, data scientists, work with natural language processing in Python. And for Sastrawi, it's basically same with NLTK, but this Sastrawi is just for Indonesian language. So while NLTK is for English language, okay? So NLTK and Sastrawi both are the libraries, are the tools that helping the data scientist, the programmer to work with natural language processing. So those are the toolkit has a bunch of libraries and program for symbolic and statistical natural language processing. And the fifth question, what is the purpose of cascoding? Cascoding is the basic pre-processing in natural language processing. It's to convert all the characters in a document into the same case, either all uppercase or lowercase, but usually to lowercase. Again, this is a basic pre-processing in natural language processing. So the basic of the processing in natural language is scaffolding. So if we do scaffolding, it will easier to go through to the next steps. Okay. So the next step after scaffolding is tokenization. Tokenization, same like that. So the tokenization is part of preprocessing data. It's also to separate word from sentence. So and remove any numbers, punctuation, and white spaces. So and then for the second question about stop words. Tell me about stop words and give example. So the next step of pre-processing is filtering that aims to retrieve important words, generate a token in tokenization process. And in this part, we need to know about stop word. It is a common word that usually appears in large numbers, and it's considered meaningless. So it's not useful for the in NLP process. So for example of stop words in English are out, I, me, he, she, but, and etc. So many stop words in English. For the example, we have a sentence that Yeppy likes to listen Metallica music, but it's not means that he is not like to listen dangdut. Okay, so the stop word is but it's not mean that he is that. So the but word is meaningless, but and then he, the important is Yepi as the subject and the listen as the, what is it, like yeah, the important is Yepi, listen, Metallica, and dangdut. So that's the important for in LP. So we can in LP, so we can like what is it, like to recommend EAP with dangdut or Metallica. So that's the function of NLP in practical example. For example, and the next question is what algorithms can be used for stemming Indonesian text? So for Indonesian text for stemming, one of the algorithm can be used for stemming Indonesian text are Porter Porter algorithm, but the one that for Indonesian language. So Porter algorithm for Indonesian language was developed by Fadilah Z. Tala. So in paper in Tala 2003, she adopted Porter algorithm in English, which was developed by Weeby Frex. Weeby Frex. I don't know the full name, so just Weeby Frex. So this stemmer is rule-based analysis to find the root of a word. This stemmer doesn't use a dictionary as a reference at all. So it should use rule-based analysis to find the root word, not using the dictionary. Going to the next question, the purpose of words embeddings. So it is to word embedding is to represent words and document that may be considered one of the key breakthrough of deep learning on challenging natural language processing problems. So most importantly, word embedding boosts generalization and performance for any NLP problem, especially if we don't have a lot of training data. So if we don't have a lot of training data, so we can do word embeddings. So to make it boost generalization and performance while solving NLP problems. And then for the next question, state and describe the architectural model of word to factor. So word to fact is a statistical method for efficiently learning a standalone word embedding from a text corpus. It's developed in Google by Thomas Mikolov. It is included in TensorFlow library to make the neural network-based training of the embedding more efficient. So the word to fact is calm because to help in word embedding, so it will be more efficient and it's help with neural network based training. Help us to work with neural network based training. So in word to fact, there are three main blocks which make up the word to fact itself. The first is vocabulary builder. This is the basic of building block of word to fact model. This takes raw data in the form of sentence and extract unique words from them to build the vocabulary of the system. The second is context builder. This is the next level converter words to vector. The output of vocabulary builder, which contain the index and count as input. And then neural network with two layers. The last block, neural network with two layers. Word to fact use the neural network uh, for training. There are following layers in neural network with two layers. There is one input layer which has many neurons as as there are words in vocabulary for training. The second layer is hidden layer size in terms of neurons in the dimensionality of the resulting word vectors. And the last one, the third final layer is the output layer, which has the same number of neurons as the input layer. And the next question is what is definition of bag of words? Bag of words in natural language processing is a technique of text modeling. In technical terms, we can say that is a method of feature extraction with text data. So this approach is a simple and flexible way to extract feature from document or text. So it's a technique for text modeling. And for the next question is tell me about fast text algorithm. Fast text is another word embedding method. That's the extension of word-to-fact model. Instead of learning factor for word directly, fast text represent each word as an n-gram of character. So, for example, we have the word artificial with n equal to 3. For the fast text representation of this word is r, art, rce, ev, v, I, and whereas the angular brackets are indicate the beginning and the end of the text. So what is the meaning of n-gram? The definition of n-gram is a sequence of n words. In NLP, n-gram are used for auto-completion of sentence, such as in Gmail, the example. In Gmail, we have, while we write a message, it has auto-completion to spell check. For example, we will say good morning. We just type good, so there will auto-completion morning, afternoon, or evening. So we just type good, and there is a option that can be chosen good morning, good afternoon, or good evening. So that's the example of use n-gram in LP in Gmail. Okay. And it also auto completion also usually in mobile keyboard, Android keyboard or iPhone. So there is a auto completion. And to certain extent, we can check for grammar also in a given sentence if we use n-grams. And the next question, describe an example of applying n-gram. For example, we have sentence website portfolio is 2 gram, a big gram. So the next gram is 4 gram, a portfolio of Yeppy, for example. And Yeppy's portfolio is a 3 gram, the last gram. So this is the example of applying n gram. And the next question is the definition of smoothing. So the definition is of smoothing. In general, the idea of smoothing is to reinterpolate counting in the training data to accompany unseen word combination in testing data. So is to find the unseen word in testing data, while the smoothing is run in training data. Okay. So the next is Laplace smoothing. Laplace smoothing is a smoothing technique that helps tackle problem of zero probability in naive Bayes machine learning algorithm. So by using higher alpha values, we'll push the likelihood towards a value of 0.5, for example, and the probability of a word equal to 0.5 for both the positive and negative reviews. And the next question is the definition of back-off and interpolation. Back-off is like going backwards, which means you go back to a n minus 1. So going to the previous step or previous n gram. Okay, to calculate the probabilities when you encounter a word with probability 0. So when you find the probability is 0, so you need to back off, going backward. So for the technical example is like that. And the interpolation. The interpolation in terminology point, the symbol are not O, but thetas. O or thetas that has a line in the middle. Okay. So interpolation is a mix of unigram, bigram, and trigram. So interpolation is combination of unigram, bigram, and trigram. Okay. The next question is explain why Knisserny smoothing methods perform so well. Knisserny smoothing is a method that most commonly applied in interpolation form. So it most used method. Knisserny involved from absolute discounting interpolation, which makes the both higher order. So Knisserny uses higher order and lower order language model, reallocating some probability mass from 4 grams and 3 grams to simpler unigrams models. Okay. And then the next question is what is the background for the development of the stupid back-off method? So Brands et al. In 2007 introduced a similar back-off but in a simpler scheme named stupid back-off. So that's not generate normalized probabilities. So the main difference is that Brands et al. It doesn't apply any discounting. Instead, directly use a relative frequency to emphasize that there are no probabilities but scores. So the stupid back-off is use relative frequency to find the scores, not probability. And the last question is what is the rationale for good Turing smoothing method? It's typically vital that the probability of the unseen object not be estimated as 0. Good Turing methods provide a simple estimate of the total probability of the object not seen. So to To see the probability of the unseen object is not estimated as zero. So good Turing method provide a sample estimate of the total probability of the object. So it count the object, not the scene. Okay. So yeah, that's the all the question is already 20 question. So yeah, that's for me. If any mistake from the spelling, from uh, the explanation, so I'm very sorry because I'm still learning English now for the yeah like talk like speech like this. Yeah, for the NLP also I still learning for yeah for my college. So, okay, so that's all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.